A complete solution of class 10 mathematics under the syllabus of Board of Secondary Education Manipur. All recorded and edited by I. Salam Meghachandra Singh, lecturer, Sursan Higher Secondary School, Imphal. Sequence. A succession of numbers formed according to a specific rule is called a sequence. Numbersingi mathang manaw naiba ama akang rule ama illabadi madubu sequence ama kawi. The numbers in a sequence are called the terms of the sequence. Sequence amagi number sing adubu sequence adugi terms sing haina khangnagani. The terms are 11 as first term, second term, etc., which are denoted by a of suffix 1, a of suffix 2, a of suffix 3, respectively. Arithmetic progression or arithmetic sequence. A sequence A1, A2, A3, An is called an arithmetic progression if A of n plus 1 minus A of n equal to D, where D is a constant. For all values of n belongs to n, the set of natural numbers. A of n plus 1 dagi A of n khaidokpagi value si matam punamakta constant D oirabadi adugumba sequence adubu AP arithmetic progression haina khangnagani. The constant D is called the common difference of the AP. Constant D asibu ka AP adugi common difference kawi. If A is the first term and D is the common difference of the AP, then the sequence is written as A na first term, D na common difference of the AP oirabadi sequence adu A plus D, A plus twice D, A plus thrice D, so on. The n term of an AP amagi n term. Let A be the first term and D be the common difference of an AP, then the AP is A plus D, A plus twice D, A plus thrice D, so on. Now, A1 is the first term which is already equal to A, which can be written as A plus of 1 minus 1 times of D. A2, second term, which is given as A plus D. This D can be written as 2 minus 1 times of D. A3, which can be written A plus twice D, which can be written as 3 minus 1 times of D. A4 can be written as A plus 4 minus 1 times of D. Similarly, proceeding, we have, looking at the pattern, we have An is equal to A plus n minus 1 times of D, which is the n term of the AP. AP amagi n term do A plus n minus 1 times of D. Formula, see the quantity 1, 2, 3, 4 yawi. Unknown ahumgi value khangabadi mari suba unknown gi value putokpa ngangbani. Chapter 6 Arithmetic Progression. Exercise 6.1. Question number 1. Which of the following sequence are AP? Karamba sequence na AP da leibage. In case of AP da leibadadi, find the first term A and the common difference D and write the next three terms. First term amasung common difference putu'u aduga mathangi term ahum amasu putu'u mo. Roman number 1, we have second term A2 minus A1. First term is, second term is 2 square, first term is 1 square, their difference is 3. And A3 minus A2 is, A3 is 3 square, A2 whose value is 2 square, their difference is 5. Thus, A2 minus A1 does not equal to A3 minus A2, A3 does not equal to 5. Hence, the sequence is not an AP. For Roman number 2, we have A2 minus A1 is 5 minus I, that is minus 3. A3 minus A2 is 2 minus 5, that is minus 3. A4 minus A3 is minus 1 minus 2 equal to minus 3. Proceeding similarly, thus A of n plus 1 minus An is equal to minus 3 for all n belongs to n. Minus 3 loina tare. Hence, the sequence is an AP whose first term is I and the common difference is minus 3. The next three terms are last term minus 4, see the common difference minus 3 absolutely minus 7. Next to the minus 7, the minus 3 absolute minus 11, 10. And minus 10 the minus 3 among absolutely minus 13. Mathangi term ahum do minus 7, minus 10, minus 13. For Roman number 3, We have a2 minus a1 is pi by 2 minus 2 whose value is half. a3 minus a2 is 3 minus pi by 2 whose value is half is being equal to half. Similarly, a4 minus a3 is 7 by 2 minus 3 is half. Proceeding similarly, thus a of n plus 1 minus a of n is half for all n belongs to n. Hence, the sequence is NAP whose past term is 2, whose past term is 2, and common difference is half. The next three terms are last term 4 asida half of 9 by 2, 9 by 2 the half 8 to syllabary 5, 5 to amo half 8 to syllabary 11 by 2. Next three term do the 9 by 2, 5, 11 by 2 ni. For Roman number 4. We have a2 minus a1 1.7 dagi 0.6 khaidokhradi 1.1 a3 dagi a2 haibadi 2.8 dagi 1.7 khaidokhradi 1.1 a3 dagi a4 khaidokhro a4 dagi a3 khaidokhro 3.9 dagi 2.8 khaidokhradi 1.1 a5 dagi a4 khaidokhradi 5 dagi 3.9 khaidokhradi 1.1 so on. Thus, a of n plus 1 minus a of n is 1.1 for all n belongs to n. Hence, the sequence is NAP whose past term is 0.6 and common difference is 1.1. The next three terms are last piram ba persi 5 tau common difference 1.1 absolutely 6.1 6.1 the 1.1 8 absolutely 7.2 7.2 the 1.1 absolutely 8.3 piramiba term sing asigi mathangi term ahum adudi mathang sitna 6.1 6 7.2 8.3 ni. Roman number 5. We have a2 minus a1 second term 5 dagi first term 3 khaidokhrabadi 2 a3 dagi a2 haibadi third term dagi second term khaidokhradi 7 minus 5 t2 a4 dagi a3 khaidokhrabadi 8 minus 7 there is 1 ahanba term ani gi difference sing du 2 ojarabasu mathang dagi 1 tare. Thus a2 minus a1 equal to a3 minus a2 does not equal to a4 minus a3 equal to dot dot. Hence, the sequence is not an AP. AP oidrabadi first term A amasung common difference di putok later. Roman number 6. We have a2 minus a1 second term minus first term is second term is minus 1 first term is minus 6 minus we get 5. a3 minus a2 is 4 minus of minus 1 is 5. a4 minus a3 is 9 minus 4 is 5. So on. Thus, a of n plus 1 minus a of n is 5 for all n belongs to n. Hence, the sequence is NAP whose past term is minus 6 and common difference is 5. The next three terms are pyramid term asi last term asi 14 asi the common difference 5 absolutely 19 19 the 5 absolutely 24 24 the 5 absolutely 29. For question number 2. Write the nth term and also the first 4 terms of the AP whose first term is A and the common difference D are given as follows. Piramiba AP amagi first term amasung common difference piramle n term putu lonena first 4 terms putu. Here A is 2, D is 2. The n term is a n equal to a plus n minus 1 d. A give value the 2, d give value the n2 picture. We have this simplified over the twice n which is n term. The first 4 terms d. The first 4 terms are a1 and the 1 picture 2 into 1 that is 2 and the 2 picture we get 2 into 2 that is 4 and the 3 picture we get a3 which is equal to 2 into 3 that is 6. And the 4 syllable 2 into 4 that is 8. Past 4 times 2 2 4 6 8 or. Similarly for Roman number 2, the n term an is equal to a plus n minus 1 times should be a minus d give value a give value 26 d give value minus 4 law simplified over the 30 minus 4n which is the n term. The first 4 terms are n the 1 2 3 4 pisulaga makhagi value singa sipangle. Mathangi first 4 term the 26 22 18 14. For question number 2, Roman number 3, here a is minus 10, d is minus 3. The n term a n is a plus n minus 1 times of the a give value minus 10, d give value minus 3. Pichula simplified over the minus 7 minus tricent, which is the n term. The first four terms are in the 1, 2, 3, 4. Pichula makagi term singa sipangle. That is minus 10, minus 13, minus 16, minus 19. These are the first four terms of the AP. For Roman number 4, A is 3 by 2, D is minus half. The n term AN is 3 by 2 plus n minus 1 times of D, whose value is minus half. Simplified over the 2 minus half times of n. The first four terms are obtained when n is replaced by 1, 2, 3, and 4 respectively. A1 is 3 by 2, A2 is 2, A3 is half, A4 is 0. Thus, the first four terms are 3 by 2, 1, half, and 0. Roman number 5. First term is 4.5, common difference is 0.5. The n term an is a plus n minus 1 times of the a whose value is 4.5, d whose value is 0.5. Simplify, we get 4 plus half times of n. The first four terms are obtained when n is replaced by 1, 2, 3, and 4 respectively. For first term we have 4.5, for second term we have 5, for third term we have 5.5, and last fourth term is 6. For Roman number 6, in a is minus 5 by 3, d is 1 by 3. The n term is an equal to a whose value is minus 5 by 3 plus n minus 1 times of d whose value is 1 by 3. After simplification, we get minus 2 plus 1 by 3 times of n, which is the n term. The first four terms are obtained when n is replaced by 1, 2, 3, and 4 respectively. That is, a1 is minus 5 by 3, a2 is minus 4 by 3, a3 is minus 1, and a4 is minus 2 by 3. Question number 3. Find Roman number 1, the 11th term of the AP 2, 5, 8, 11, 14, so on. Pyramid by AP sige tarama subu term putu. Here is 2, d is 5 minus 2 second term minus first term gives the common difference d. Therefore, a11 is first term, a is 2 plus 11 minus 1 times of common difference, that is 3. After simplification, we get 32. For Roman number, thus the 11th term of the AP is 32. For Roman number 2, a is 4 and common difference is second term minus first term, that is 1 minus 4 minus 3. Therefore, a15 is a whose value is 4. 15 minus 1 times of common difference minus 3. With simplification, we get minus 30i. Thus, the 15th term of the AP is minus 30i. Question number 3, Roman number 3, the 20th term of the AP. The 20th term. Here, a first term is 1, common difference is second term 3 by 2 minus first term 1, whose value is half. Therefore, a20 is a whose value is 1. 20 minus 1 times of common difference whose value is half. After simplification, we get 21 by 2. Thus, the 20th term of the AP is 21 by 2. For Roman number 4, here a is root 2. Common difference, the second term minus first term, we get 2 root 2. Therefore, a18 is first term, a root 2 plus 18 minus 1 times of common difference, 2 root 2. After simplification, we get 35 times of root 2. Thus, the 18th term of the AP is 35 times of root 2. Question number 4. Is 67 a term of the AP? Pyramid by AP SCG 67 si term mama oibra. We have A is 5, first term is 5, common difference is second term minus first term, that is 3. Let a n equal to 67. 67 si n sub term ni hane loksele, but a n ki formula di here a5 plus n minus 1 times of d whose value is 3 equal to 67. Solve n from we get n equal to 65 by 3, which does not contain in n. Thus 67 is not a term of the AP. Term masing haibasidi natural number oigadabani mafhum asidadi 65 by 3 si natural number oidre aduna 67 asi karigumba term amagi value nate AP asigi. For Roman number 2, we have a first term is 10 and common difference d is second term 6 minus first term that is 10, whose difference is minus 4. Let an equal to minus 204. Minus 204 as the n suba term ne hane but an did 10 minus n minus 1 times, so d whose value is minus 4. N solved already, we have n equal to 218 by 4, which does not contain in n. Thus, minus 204 is not a term of the AP. Pyramid number asisu AP asigi term ama oibra oide. Question number 5. Which term of the AP? This is 1 to 4. AP asigi karamba kaya suba term na 1 to 4 oigadage. Here A is 4, a common difference D is second term minus first term, that is 5. A and 1 to 4 C n suba term ne piramle. Using a n to n term formula panjulabadi equals masi phangani n solved already 25 masi natural number ni. Thus 1 to 4 is the 25th term of the AP. 1 to 4 as C 25th term ni AP as 25th term ni. Which term of the AP is 0? Pyramid by AP as kaya suba term 0 igani haven masi n suba term ni lokselasi. Otakiruma number 1 gamanana. Here A is the IT for first term, D is common difference which is obtained when second term minus first term, that is IT minus IT4, that is minus 4. But 0 is given as n term. We have to find out n. Using n term, we have IT4 plus n minus 1 times, so D whose value is minus 4, whose value is 0. Simplify n from here, we have 22. Thus 0 is the 22nd term of the AP. Question number 6. Find the number of terms in each of the following APs. Makagi AP singasida number of terms putu 7, 10, 13, last term na 43 ni, first term na 7 ni. Here A is 7, common difference is second term minus first term is 3, n is 43. We have to find out n. Using this formula, n term formula, we have n di 43 pislani a di 7 pislani n di putokadabani d gi value di putokara 3. Mafam asidagi aikoina n di solve tawrabadi 13 phange. Piramiba term masing asi number of terms APSC ki number of terms 13. Thus the number of term is 13. For Roman number 2, A, D, A, N putokadabani. Using an equal to a plus n minus 1 times should be. Using this formula, we have an is given as minus IT6, a is given as 4, n is to be found out, d is already found as minus 3, from which we have to solve n. N solved 31. Pyramid by APSC number of terms upon the term is 31. Thus the number of terms is 31. Question number 7. The n term of a sequence is 2 minus 5n. Is the sequence n AP? Sequence amagi n term the 2 minus 5n is sequence si AP da leibra. If so, lairabadi find the first term and the common difference put to u. Here an is this. Therefore, show a of n plus 1 and n plus 1 since occur so n plus 1 since simplified or any different. Now a of n plus 1 minus an. Respective value 0 right simplified over the minus pi, which does not depend on n was the n constant, or for all values of n belongs to n, the set of natural numbers. Yes, the sequence is NAP whose first term a is n the 1 pisulaga phangi minus 3 and common difference to the minus 5 mataka minus 5 percent. Question number 8. So that the sequence whose n term is this is not NAP. Karigumba sequence amagi n term to 2 power 2 times of n square plus 3 whatever the madu AP the layroi have. Here a n is this. So a of n plus 1 and n plus 1 to simplify to the Mabani difference putoxi a of n plus 1 minus a of n is equal to respective values are their difference gives 4n plus 2, which is not a constant as n, which contains n. Masi n yawan in a constant oidre. Thus the sequence is not an NAP. N term pyramid is n term of a sequence do AP the late. Question number 9. Find the 15th term from the last term towards the first term of the AP. AP asigi last tagi 15 suba term adu last tagi makok lom the changa for the 15 suba term to put to u haven. Here A is 1, 2, 3 last term sina first term loxulan D last second dagi last term khaidokigani. That is obtained in this 3 dagi 7 khaidokani. Last term dagi last second khaidokani. See first term dagi last second khaidok the common difference phongani. But in the reverse the sequence same using this formula we have a 15 ni last dagi 15 subadi a gi value do 1 2 3 pirani 15 subadi and 15 pirani d minus 4 phangare mafam asida d puto ko je khangsin gada bani a 15 na dugi value do icon simplify to 67 phange sequence asi gi finite sequence ni aroi be tam lay aroi be dagi amo mamang lom da lakpa matam da sequence ama sengwani aroi be sina first term logani. The 15 term from the last term is last term the 15 super term is 67 or any. Question number 10. In NAP, the fifth term is 7 and 11th term is 10. Find the first term and the common difference. AP amagi mga super term is 7 ni 11 super term is 10 ni first term amasung common difference adu putu hariba term ani adu A amasung D logsilasi. Here A fifth is 7, A7 is 1, A is what, D is what. Using an equal to a plus n minus 1 times of d, we have respective value pero a7 is 7 pirani, a5 is 7 pirani, and the 5 is law a unknown d so unknown. The equation ama pang a d yawa ama matangi amoksu is a7 value 1 a7 value 10 or bani this must be 10 or A Amazon 11 super term having this must be 11 this must be 11 this is 11 or 11 simplify to equation 2 phange 1 amasung 2 dagi eliminate to si a gi coefficient mana rabanina 2 dagi 1 khaidokhrabadi 6 10 d dagi 4 d khaidok 60 lare 10 dagi 7 khaidokhrabadi 3 lare d gi value half phange hariba d gi value si 1 natraga 2 da sinjalaga a gi value putoksi masi equation 1 da sinjala si d gi value the half sinjalo aikone a gi value 5 phange. Thus the first term is 5 a gi value and the common difference d gi value the half phange. 11. The 6th and the 17th terms of NAP are 21 and 54 respectively. Find the 40th term. So 6 suba 11 suba term sing atu mathang sina 21 amasung 54 orabadi 40 suba term gi value puthu haibani. Here A6 is 21, A17 is 54, A40 is what? Using this formula we have a60 21 a d putokadabani and 6 pisula d putokadabani simplify to equation 1 phanga sumna a amasung d yaw equation amaga putoksi a17 dagi a17 equal 54 dagi a 70 period a17 value de 54 ni and 70 pisula ni simplify to equation 2 phanga A gi coefficient manarabanina elimination method na khwaidagi most appropriate method or 2 dagi 1 khaidokhrabadi 16d dagi 5d khaidokhrabadi 11d 54 dagi 21 khaidokhrabadi 33 machidagi aikune d gi value do 3 phange common difference khange 8 kangare d gi value si 1 ataka 2 sinjalaga a gi value putoksi question 1 da d gi value adu 3 sinjala manga trama dana 21 dagi khaidori 6 phange a amasung d khangabadi. Therefore, a 40 times the a plus n minus 1 times of the formula a value 6, the value n value 40, the value 50 shall simplified or we have 1, 2, 3 hunger. 12. The 15 term of NAP exists the 20 term by I. Karigumba AP amagi kun suba term dagi 16 the 15 suba term dana nipan hele find a common difference to high bani. A 15 suba term dagi 20 suba term do khaidoga I phang. Let A and D be the first term and common difference of the AP. AP adugi first term dona a common difference the D log see. Since this we have a 15 value the a plus 15 minus 1 times of the a 20 value the a plus 21 20 minus 1 times of the equal 0 eliminate over the d value the minus I by 5 I by 5 a common difference of 2 high bani 13. How many two-digit numbers are divisible by 3? 3 na yemba yaba two-digit number masing kaya laigadage. The two-digit numbers divisible by 3 are 3 multiplication. The two-digit khwaidagi piku two-digit t12 ni two-digit to khwaidagi chawa 3 multiple to 99 ni. This is an AP whose past term is 12 and common difference is 3 3 orani. Using this formula, we have A and the 99 pishilo, A the 12 pishilani, and the putokatavani, D value 3 pishilo, and solve torabadi, N value 30 pange. Thus, the number of two-digit numbers division by 3 is 30. 3 ni yaba two-digit number yapun number 30 ni. Subatangi value na 1 by M ni M into N subatangi value do 1 oigani ulu heaven. Here, for the AP, AM, M subatangi value 1 by N and N subatangi value D 1 by M piramle. Using AN equal to A plus N minus 1 times of D, we have AN ki jagada 1 by N pisilani, A di lengdana thamani, N the M subo orabani na M pisilani, D lengdana thamani. Question 1. Similarly, N subatam dudi 1 by M pisilo formula the out of N adumak pisilasi. We have equation 2. 1 dagi 2 khaidu asi A eliminate taunanabagidama A gi coefficient animak same magnitude same sign in equation 1 dagi 2 or 2 di 1 khaidu ni mafam asida 1 dagi 2 khaide. We have this mafam asida gi koina amok D to solve torasi D solve toradi 1 by Mn phange. Putting D gi value 1 by Mn in equation 1, we have this. Sidagi A amuk solve tausi A solve torabadi 1 by Mn phange. A amasung D khanglabadi Mn subatam do D. Thus Mn term is what A gi value the 1 by Mn pirani do Mn subo orabanina and Mn pisulani D gi value D 1 by Mn. Simplify torabadi we have 1. Hence proof. Question number 15. If A, B, C be the P, Q, and R terms of an AP, prove that this expression equal to 0. A, B, C na P suba Q suba R suba term ni AP amagi. Let X equal to first term and Y equal to the common difference of the AP. Using this formula, we have A and the AP syllabadi P ni and the P syllabadi Y the D A the X equation 1. Similarly, equation 2 is similar, equation 3 is similar, equation 3 phange. 1 dagi to equation 1 dagi 2 khaidu asi x mangki nabagi dama equation 4 tolasi amuksu 2 ga 2 dagi 3 khaidu asi x mangki nabagi dama equation 5 phange. Ani asi divide tonaraga y manghalani. Roman number 4 the equation 5 ni yellow we have this, cross multiply we have this. Object section gada badi A times of Q minus R yaurabanina A na Q minus R puri baduma di mapumo na tamasi. C times of P minus Q yaurabanina minus of minus C plus C ni maduma lairani. Minus P na Q minus R puri badu lengana tamani. Minus P na P minus Q da puri baduma tame plus C na da puri badum laire. Mayagi tam ani si ahan batam ani asimadi aikona apamba expression or apamba expression. Sigi tam simadi apamba expression or. Jig B yawa tam ani silagi B kamal logthokisi B kamal logthokabadi we have this. Jig Q ani se kakthanagarasi minus Q ka plus Q ka kakthanagarabadi we have makagi expression asi phange asina puthokadaba praman tawgadaba to exact tar. Hence proof. Question number 16. A sum of rupees 5,000 is invested at 6% per annum simple interest. Rupa lising mga si sahida 6% kabada simple interest na sandu e. Calculate the interest at the end of each year. Sahi kuding aroy bedal pangba interest in putu u so that they form an AP makoni AP ama semi hybrid su utlu. Also find the interest at the end of 25th year. Sahi kun mga subadal iba interest adu su putu u haibane. The interest at the end of the past year, we have this karigino a simple interest protocol formula D PRT by 100 palani. P this layer 100 T rate T R D rate ni 6 learning time D 1 year ni 100 ni year learning we have 300. Similarly, at the end of second year, so the T the 2 pixel learning 600. At the end of third year, so T the 3 pixel we have this. Assume proceeding similarly. Thus, the interest rupees at the end of first, second, third years are mathang sina rupees 300, 600, 900, and so on, which are in AP, and whose past term is 300 and D common difference is 600 minus 300, that is 300 or Using this formula, we have A25T, A25T, A the 300 pirani, A the 25 pirani, D the 300 pirani. Simplify to the 7500 Thus, the interest at the end of 25th year sahi kun mangagi aroibida leiba aroibida phangada batno sendo listing tare chawan. Question number 17. In an auditorium, the seats are so arranged that there are 8 seats in the first row, 11 seats in the second row, 14 seats in the third row. Auditorium amada row nipas. Ahanba sita ahanba row the seat nipalay ani suba row the sitara matwelay ahum suba row the sitara marile asum satarakani, thereby increasing the number of seats by 3 every next year. Next row khudingi 3 seats hengalakani. If there are 50 seats in the last row the 50 seats later badi, find how many rows of seats are there in the auditorium adu the row kaya laibagi. The numbers of seats in first, second, third rows are 8, 11, 14, so on, which are in AP whose first term A is 8 and common difference is 11 minus 8, that is 3. Also, if AN is 15 last row the 15 row masing kaya na n puthokadarim ni. Using this formula, we have AN ki value the 50 PC law A the first row the seat nipal lay. The number of row n puthokadabani common difference to 3 ni. Chidigi n the solve to rabadi n ki value 15 pange. Thus, the number of rows of seats in the auditorium the level rows singi masing as 15. Thanks for watching.